Can y'all hear me? And then this will be the last Wednesday stream until December, because I'll be going unless I can do one maybe I could maybe try to do one on the at John's and Nancy's place next week. But probably not. I'll probably just do the Thursday stream at their at the Nancy event. All right. Anyways, guys. Um, can y'all hear me? Make this live. Okay, so let's see how many people we're in. So we have two people or likes, two likes. Okay, anyways, today's gonna be a pretty interesting setup here. I'll be going over again my notes and so on. Planck. Yeah, we're gonna go over Planck length and a bunch of notes here, but I also want to continue with the Einoldignu paper because I'm pretty sure that's what everything is. Just sound, ether sound is light and so on. It sounds great. Good time. So sounds great. Okay, I'm gonna have a quick listen as well. Um, Planck. Yeah, we're gonna go over Planck length and a bunch of notes here, but I also want to continue with the Einoldignu. Okay, yeah, that should be fine. And I should make this a bit wider, maybe. Make this like this. Okay, and then make this wider. Okay, that's cool. All right, okay, yeah, Tammy, great to have you on the show. And I also want to see, yeah, so Tammy, I want to see what your, I think you had a, Paintress is your name on Hive. And I'm gonna get Beneficent TV, I got an account as well. Let's see, I think you, had, I actually want to go back to see how much, your wallet's worth now. So you're at $3.82. Okay, epic stuff there. That's pretty epic. And then make sure to claim. So your last time you claimed was 20 days ago, so you can claim every 7 days. And so on for each post relative. And so you have that much. And I think you have Pixa Bazaar. Yeah, paint and then Pixa, no Bazaar. I mean, Mystic Bazaar. I think she's already yeah. So she posts a lot. Oh, and I think she has a decent amount now. She has at $5. Unbelievable. So and also these are Peak support. Okay, make sure to vote on these as well. If you're using Peak and so on, vote them as witnesses and so on. And you also get a I think they might get like higher chance of getting upvotes from these big accounts. I don't know how to claim on my phone. Well, you can claim with your Hive keychain. So just open the keychain. Okay, 29,000 tons, guys. Iranian guys back. Iranian. This is not a drill, guys. I will pop this out actually. Oh yeah, so I forgot to yeah, share stuff. Okay, so I should be doing. Yeah, so today was just all over the place. Okay, need. Okay, this is yeah, you definitely get more surge. I have a bunch of that token. It's like a stable slash yield bearing token. Anyways. I'm gonna quickly just yeah, I'm just all over the place. I'm gonna go like right here, copy this. Yeah, I should have shared stuff. I completely forgot what I was doing. Okay, I'm gonna do a quick thingy here, and I'm gonna go threadcast, and then we'll get in the show. Yeah, and here's what I usually do, and go right here, and I'll upload this. And yeah, no, I'll read the 29,000 tons. Yeah, how are you doing? I'll read you sent a bunch of messages on the MES links chat, so I'll read that and see what happens. And also, am I looking like this is right? This is look straight. Okay, I'll just go straight here. I just don't know how I look when because I've looked actually this is how you do it. So I just look at okay, there it is. Okay, so there it is. This is my big nose there. Okay, so make it a bit to the side. Okay, so that's pretty cool. That's how you look at it. Okay, so I can move it in the front, and then I can see myself. Okay, anyways, I'll do this and open this 1 second. Just bear with me for a few, and then, and I just made an epic video for Nihil Revisionist, and okay, so okay, so here's the threadcast. I'll be posting stuff here on the threadcast as well. And again, because I hold this LSTR token, I also get these upvotes from this right here, which is pretty cool. Again, Hive is like ridiculously cool. Okay, okay, this is right here. Okay, so anyways, I'm gonna go and read the Iran stuff here. 1 second, I'm just trying to get some set up here. Okay, this is how it is. Okay, Iran. Okay, this is Iran guy. Oh yeah, so yeah, because last weekend I was doing the Tesla coil and I just saw your messages. Are you going to do something with it in it live? And I said the Tesla coil is live. Also, how are things in Iran? All right, so let's see. I think you got back on. I'm busier than ever working a 2.5 jobs. Okay, so you're 2.5 men now. Let's go. Okay, so Smucker Pablo's in there. Okay, Smucker Pablo's in there, and then is emojis is that some guys kissing or something? Okay, that's a bit wild. Um, just comment down. Okay, and then how do I like see stuff? Okay, so I think you got back in here. Okay, so it says here, so how's everybody? I started a new job, lost my phone on the first day. My whole life was on that phone. Anyways, I managed to recover my email information from my old PC. And the first video on my timeline was this 33. Okay, epic. So yeah, this weird 33. This guy is okay. This guy's definitely an agent. Okay, so I got people like I got the Stephen F and the Charlie saying, hey, give him a chance or whatever. I'm like, nah, this guy's definitely wild and um yeah. So this guy right here. Okay, so 33. Let's open this up. But also could you set all your whole life on your phone? Like definitely get some cloud storage. Because you can get OneDrive or Dropbox or any other alternative. It's just have it always backed up. Because like everything I do, I make sure everything's backed up. Like I literally have every photo, pretty much every photo I've ever taken with any phone I've ever taken, it gets automatically put in the cloud on the on OneDrive, and so on. And yeah. So in case because I think it happened back in the university. Actually, somebody stole my laptop. It was inside somebody stole my whole backpack, which had my laptop inside. When I was at the gym, and I'm like, my goodness, okay. And then I'm like, okay, I gotta get everything cloud storage, everything when I was at university. All right. Anyways, guys, yeah. So show Iran's Freemason problem building that we talked about. Oh yeah, we'll show that in a bit. Okay, this one here. Oh, does this show it or does it? But anyways, it's 33. Yeah. So this guy here, and I think he asked. Yeah, yeah, he's finally love what I'm seeing. All good. I started a new job. It's physical. I don't even have time to scratch my head. Also, I lost my phone. Okay, well, yeah. What is your job? Are you building nukes? Charlie Max says, "How's Iran doing? Did they get their nukes yet?" Also, what a coincidence you showed that video. I just watched like 5 of his videos last night. Very interesting how so many Masonic buildings have 33 on their addresses, and some lead to secret underground tunnels. Interesting. All right. Okay. Also, something I didn't know that he showed was a number 10 and how it signifies. According to him, soft power Chatham House is on 10. But also Messi is number 10. Also, I wear Matisse is number 10. Caxton Hall's on 10. Of course, 10 Downing Street, where the Prime Minister resides, and many more. I think, okay, going right here. Okay, this is very interesting with Bob Greener going over unique Tesla homopolar motor design, which he believes may have led to Tesla witnessing Hutchison-style effects at 1:16:30. The core of the homopolar also covers a fascinating experiment involving a spinning disk that's buried to disturb ether and deflect laser paths. Okay, I'll open this as well. So we got some. Anyways, so Wednesday streams are more science technical stuff, just because that's what matters. That's the one thing you'll notice in like almost 99% of all alt media, even mainstream. It's like they don't do any technical stuff, and if they do the technical, it's usually just a inviting some random guy to talk about it instead of them actually getting in the nitty gritty. All right. Okay, they're going to blow themselves up. Up building 1 can manage natural water. Yeah, as soon as I load my timeline, it popped up. Interesting video, 33 all over with no shame. Okay, let's see some elsewhere here. I'm halfway through this, which I was president of this live stream. Anyway, 2 things. 1, this was a governmental building, yet I couldn't find any CCTV footage of the alleged, quote, explosion. Pentagon deja vu. 2nd, I wanted to watch quote, terror video similar to this one for comparison. I believe this is some footage from Iraq, but I couldn't find any that exploded. Besides a building in the OKC case, it looks like Godzilla took a bite out of the building. Yeah, definitely. The photos of the destruction of the Gaza could be a source comparison. Yeah, and there's another comparison we could show for the 9/11 one. It's pretty wild. Is there anything else here? Okay, so we got okay, and this one's pretty interesting, but bald by design. People's going after my hair. Sounds hectic. Yeah, 29. Okay, Gary Jackson's here. Okay, yeah, Gary Jackson was also pushing through the board meeting and dealing with a bunch of other stuff like that. Like, anyways, one of the secret tunnels are marked by the number 33. Okay, so we got a whole bunch of 33 everything, but this guy is obviously okay. Anyways, that guy is obviously the reason. Okay, then there's some stuff here. This guy's very good, but interesting. He is appearing on our feeds. Can confirm he is Judy Pill, describing the towers disintegrating tornadoes. Yeah, but he never mentions her name, and there's no search in any of his social media with the name. Not even 9/11. He like hides that wording from his videos and his Twitter and so on. On video, looking at Iraq War Memorial. Anyways, and then I sent this link right here, Reality of Nanothermite on December 16th, December 2011, and again, I think it's 12. No, never mind. Yeah. Anyways, it's a disappointing video from 2011. Now, not and that he hasn't taken down or corrected it, but this is a video from 6 years later with a teardrop-esque Iraq monument in which he used do-style language. The Twin Tower just disintegrated in midair. They look like nothing was there. But again, that's more telling that he knows more than he's willing to reveal. But then it's like, well, if you're not talking about 9/11, why talking about number 33? Like, what's the actual point of talking about occult numerology if you're covering up literally reality deification like magic? Okay, most likely wasn't aware of the evidence. He promoted Stephen D. Jones. And then Stephen F. made a good comment. Yeah, yes, but I'm in two minds of on him appearing on our feed. Either he has beaten the algo by vanishing for 7 years and coming back with content for people who are awake, or he's promoted. But so far liking stuff a lot. Aside from the dreadful video MES unearthed, always slaying my influencer heroes. Yeah, that's what I do. Again, the litmus test is very, very simple. Like, talk about 9/11, get it right, or what's the point of even like talking? Okay, and another thing is you'll notice a lot of these alt media guys, they know a whole lot about Freemasonic symbolism and all this. Yet that's a giveaway that they're literally Freemasons. Right, so like here's the other thing, and also another part is saying protest equals data. Just as 2 days ago, 20,000 views. You can't make this stuff up. How do you get so much views? And when did he just come out of nowhere? Yeah, so he went from 6 years, London blackmailed by New Age death cult. Okay, and then jumps all the way to 3 months, and all of a sudden getting like a huge amount of views, like 20K views, and he's saying protest equals data, basically saying don't protest, they're gonna get your face into. I'm like, what? I didn't even read the thingy, but anyways, so if you search Judy, nothing's there. If you search 9/11, okay, thoughts on Boston bombings, and the constant use of the twin bombings is a lot of newspaper tell us. Okay, and this is 12 years ago. Weighing the evidence, coincidence theory. Okay, so he doesn't mention that, and then he says thermite. And if you go right, thermite, reality of nanothermite. Okay, there it is. It's like thermite's the anti-litmus test. Okay, anyways, and the fact that it's like, again, it's one of these weird where he doesn't want to mention 9/11. That's again a huge giveaway. And then he mentioned Stephen E. Jones. I'm gonna go to like, how could anybody? Anyways,
of scientists, one being Stephen Jones, the other a scientist from a university in Holland. Now, they did a scientific paper on their analysis of the dust.
The dust. Okay. Anyways, it just I can't handle it. Please, guys, like, please. Anyways, I'm here to. If somebody could confront him, get him on saying stuff, and also if you go to his X account, who's he following is a better question. Okay, Carl Benjamin. Okay, and if we go do 9/11, literally nothing. I was like, what are we even doing? Let's go do number 33. Okay. The new Iraq memorial weighs in at 33 tons. Pretty obvious. Okay, that's pretty interesting. Yeah, but pretty obvious what? It's like everything is just an allusion to something. And anyways, that's that part. What else did we have in the? I think we had a bunch of emails. All right. Anyways, guys, and let me know if you have any. Okay, we got some BMW questions. Sandy, it's Sandy Hook. Who checked the patsy was Adam Lanza. Oh yeah. So his mother got killed there somehow. Nancy Lanza. She comes up as a 666. That's pretty interesting. Have a great day. Okay. Nancy Lanza is the name. Very interesting. As well, checking names. I remember from the Waco mass ritual, the Davidians who were. Okay. So anyways, he's in gematria. You probably mentioned this before, but New York is 6662. Funny enough, Springfield comes up with 119. You know, the Simpsons did it again. Okay. Okay, this is this is Jordan Maxwell. Wait, he's talking about 9/11. It's good stuff. But also, you also mentioned where the towers go, just in case you find interesting. Okay, this is we're breaking grounds from the thingy here. Anyways, I'll try to get into more science technical stuff, but I want to get over to his Patreon. We got some epic stuff here. And also, guys, remember, I can ask any science technical stuff in the chat, and I'll get to it, and so on. Okay, and I want to go right here. This is Jordan Maxwell. I just got suggested this, which has been has to be old because the guy passed through where he's got good stuff about Freemasonry, but also tons of disinfo about other topics. He mentioned where towers go, just in case you find it interesting. Okay, let's see. Oh, this is a different guy mentioning it. Oh, this is Jordan Maxwell himself. Let's see. When does he actually mention it?
For educational critical
His work, where towers go, but why is it? Okay, what is the thing?
review and reaction is the late great Jordan Maxwell.
And all kinds of strange things going on in the ocean, of the Atlantic Ocean.
Okay, he's talking about Atlantic Ocean, and let's say Judy. When does he mention Judy? Who's? Okay, where's the book? By the way, what the drama with Nancy Hutchinson. Hutchinson. Not get that remove the end. Remove the end just because Nancy will attack you and I will attack you too. Everybody gets it wrong. Yeah, so this is where's the book though?
Incredible stuff. That space shuttle, when the space shuttle first went up, they had special cameras on the space shuttle.
Mm-hmm. Where's the 9/11? Okay.
Shuttle. They took up and
where's the actual thing? Like, what are we even doing?
World to just sink into dust. They just went blue. That was it. They're gone. How do you do that? Well, I don't know. The article said back in 1960 or 61 when they did the first space shuttle, they said that it was carrying a laser, an industrial-sized laser that can melt a high-rise. That's what the article.
Okay, so I'm a laser from space. Okay.
Said. Well, the collapse of the World Trade Center, when it collapsed, normally it's over 100, I think it was 105 stories high. It's over 100 stories high building. Anything that's over 100 stories high, with all of that concrete and desks and chairs and files and bathrooms and toilets and everything else, if that's going to come crashing down, you would think there would be at least 20 stories of junk, of trash that it falls down. It will fall down until all 100 stories are crushed into 20 stories of junk and trash and toilets and chairs and desks and
okay. So
all kinds. Where did the chairs and desks and all the bathroom fixtures and the lights and all the doctor, a lady doctor who did some research on 9/11, which shocked me. It was incredible what she found. She's got pictures on her website of cars, automobiles that are half a mile away.
Okay, so he mentions, yeah, so he knows about Judy Wood. Okay, that's pretty interesting. But it doesn't
4 or 5
Woods.
pictures on 9/11, Dr. Woods.
Woods.
I forget her first name. Dr. Woods. Lady doctor. Her last name is Woods. Woods. Dr.
What the hell is with DS? Like,
Woods. Okay. I forget her first name. Dr. Woods.
but at least I give him some slack because he's super old.
9/11. Mm-hmm. And it's called 9/11.
Okay, so he got that right. So that's pretty interesting. Type, but yeah, no worries. Okay, 9/11 versus good evening. A bunch of crazy. Let's go. Yeah. So that's pretty wild there. The link for the YouTube link is in the Telegram right here. I mean, yeah, Telegram right here. I put there. So that's pretty interesting. So Jordan Maxwell actually got on it before his deathbed. That's pretty interesting. That gives a lot of credence to him. But he calls her Woods and the first name. It's like, well, come on, everybody. But no worries. Not a revisionist. Good evening, a bunch of crazy. Let's go. Okay, yeah. So and he also sent some stuff here. Don't use your face or finger to lock your. These can be used against your will to unlock them. Stay strong. Yeah. Yeah, that's interesting. I try to avoid putting my fingerprint on anything. I just don't understand. Like, well, the thing is, I don't have an issue with passwords and so on. Yet. Okay, it's general. Okay, this is the video idea that Nyland just asked me to make. General idea is fine, but the Russian one needs to play first, and the voiceover with with Twin Towers tipping over. I'm gonna play this video right here.
At the beginning.
So this is there. So you want to play this first, and then that after. Okay, but so this is the Russian building where they're pulling it down, and notice how it slams to the ground super hard.
At the beginning of its final destruction, World Trade Center 2 tipped.
And another thing is, what people don't realize is this is like a tiny, tiny building compared to this one. Okay, yeah, so he wants to play this first, and then that, and so on.
Or twists to the east, but turns to dust before hitting the ground.
Okay, 29,000 knots, on mistakes, pronouncing her name, dude's like 93 years old. Yeah, I know, but the thing is, everyone, it's always Woods. It's probably got it from some other guy. But it's like, the pronunciation has to be the exact same, this info one, at all times. And the guy's a bit wilding with his philosophy, I believe.
The tipping top falsifies the claims by NIST that it was an inevitable collapse.
If the leaning top had fallen as a rigid block, it would.
Yeah, so see, they're pulling it down, but again, this is tiny. This is like massive, and like, like the block here is bigger than this building. The block that's on 9/11 WTC2
would have landed on World Trade Center 4. When we look, it is not there. Not only is it not there, but neither is the main body of World Trade Center 4 itself.
Yeah, and Matthews, everyone always thinks of Tiger Woods. Okay, that's interesting. Tiger Woods was a disinfo agent. They put his name. His name was Wood. They just added an S to change up Judy Woods one. Anyways,
that was a big aha moment for me about the tipping top. It looks like it stops tipping and it looks like it goes straight down. Well, if you look at angular momentum and you're going to obey the laws of physics, it does. But what it does is prove that the building is no longer a rigid body. You know, the whole thing, tipping, has angular momentum. If suddenly all of that top portion turns into little itty-bitty specks of dust, each one can keep rotating. So the whole thing doesn't continue rotating as a rigid body, but each of the little specks rotates. And that way it conserves angular momentum and doesn't violate the laws of physics. So that's a way of proving that the top turned to dust.
In this video, we can see that some of the core.
yeah. See, this how it's coming down. I just want to check what the height is, because again, here at MES, I am a mathematician, and I need well, because I guess people don't realize math is like one of the best. It's like another data point you can add. You can just look at something visually, yeah, but what's the scale? What's the numbers? See, I just want to see what the height. What building is this, anyways? I'm gonna go to 10i or Google. The way they inner core frauds from that one view, how can people not see it? Yeah, that one. Is that the South Tower one? Yeah, that South Tower one is pretty wild. Which is this one here? This is the complex. Okay, this is the building. Okay, what is that called? After column 300 and over 100 calls buried after column fraud. No, why would it? Okay. Oh, they were trying to pull down it sideways. What were they trying to do? I'm gonna go to building wiki. That suggestion is too fluid. Like, what is going on here? Building collapse. Suddenly broke off, and so this wasn't supposed to happen. What's this supposed to happen anyway? Okay, building was in Snitsko. Everybody just type in like on their keyboard around. But what is this supposed to happen? Like they're pulling it literally. It gone wrong. The reflying. But like, but they're still pulling it down. What did they expect to happen? How could it? Like, I'm completely confused. Like, what is in the world supposed to happen? They're pulling it, so you expect it to fall. Okay, I'm gonna go and ask. Okay, I'm gonna go ask Rock. What's the? They're taking apart piece by piece. So I know, but like, what were they? I know, but they're pulling something. How big of a piece were they trying to pull? How How tall was the building in Russia that had the Russian accident? Let's see what is what. Oh, I'll just do Alt. Let's do it quickly. Just make it auto. They're taking apart piece by piece. Yeah, but they're pulling it. Like, I don't understand what you mean. What do you mean? What are they taking apart? A little tiny piece? Where is the... So they were trying to take a little tiny piece. But, like, pulling it from that angle. And where... I'm still, like, confused. Okay, so they're pulling... But they're pulling there. They wanted a little piece of it. Not the full thing, but it's still going to fall down and do stuff. Okay, this is absolutely wild. Okay, 25 meters tall. Okay, and then so 25 meters, and then the WTC, what is that in feet? Yeah, so okay, what is that in feet? And compare with Twin Towers height. Okay, they're breaking the building apart. I know, we all know that. You've said that many times. I'm just saying, how big of a piece are they trying to take off? They're pulling it down. But what were they expecting to happen? Like, so 82 feet. That's literally 82 feet. It's 6% of the height of the Twin Towers. Okay, so it's 82 feet. It's about 8 floors high. And then the top 20 tower, yeah, top 20 floors. So the actual chunks in the this one. This is 25 meters or 82 feet. This is 1,368 feet. And what is that in meters, man? What is this? 1362 feet to meters. Ask floor how many it should be about eight floors. Roughly floor is 10 feet. It's about roughly 8 floors. So it's about 400, yeah, so 450 meters. How many floors was the building? Okay, it's gonna be it should be about eight-ish, but if it's condensed a bit more. Ski facility designs large single volume elliptical structure, continuous slow slope, rather than a multi-story with discrete floors. It literally has a discrete floors though, isn't it? Especially some ski one, but it's gonna be, let's say, a one. Actually, no. This is probably. I think we got the wrong building. It's not. It's got. Yeah, that's not 25 meters. It's got to be something taller than that. 82 feet. Okay, what is? We get the wrong one. Yeah, this is the right one. Okay. Complex. Oh, yeah, 25 meters high. Pretty powerful burst of stone. Okay, the falling barrier struck nearby. Expected, yeah, so the building is shorter than the expected rubble height. Yeah, it's much shorter. It's literally less than the actual size of the block. This block right here that's coming down, this one right here of South Tower, this block is about, yeah, that's about 20 floors. Yeah, it's more than double the height of this. It's more than double the height of the building. So, like, people don't realize the scale. The actual block is more than double the height of this building, not this block. And then look at this giant thud from this little tiny block relative to the WC. So if you put it to scale, it's like literally like bananas. So again, this is why I'll say scale and like learn mathematics and ratios and percentage. Like if you go right here, Iran model. Okay, so this is what I mean when if you just look at the scale, like this building right here in Iran that collapsed, there's the size. Look at the rubble. Look at the big giant. This is a truck. Look how big the rubble is compared to the truck. And then this truck's right here. It's really ground level. And this is like building 4 or something. It's like towering above. But if you look at the scale, yeah. So the scale. This is the building. is like just slightly taller than building 4 and 6. So, and it's shorter than building 3. So this is what I mean by scale. Like this is, see this right here? That's the size of this one here. And that's gonna be probably the same size as the other one. Okay, what is the Tehran building? How tall is how tall is the Tehran building? Plusco building. How tall is the Plusco Iran building fire? Oh, by the way, there's no running water at night. Here, dams are dry. No rain at all. It's mid-autumn here. Saudi Arabia manipulating the weather. There was snow in Saudi Arabia last year. Okay, that's literally what Dane Winged's saying. 61 meters. Okay, so this is 61 meters, 200 feet. So the Plusco building was a 16-story. Yeah, so it's pretty much, yeah, double. So this building right here, this building is double the height of that Russian thingy. So it's double the height of this one. So again, when you look at the scale is like, we're talking astronomical difference. Okay, so it's like go driving to the local store versus driving to the moon. So this building is less than half the height of this one right here. Where's the other one? Less than half the height of this. It's gonna be like where my mouse is, and it's like what in the world is it? It's literally absolutely nothing, and yet makes louder noise than the 911. Okay, yeah. So anyways, Iran is Walden. Okay. This is some other stuff. Okay. Anyways, we have 32 minutes in the stream, and we should power through some other stuff. I'll do that in a bit. What else we have in here? Okay, but yeah, it's a good thing Jordan Maxwell got onto the WTC. All right, I'm gonna close some stuff. I'm gonna go over. We'll go over to the Planck slang stuff. Okay, so I have some stuff here, but before I even get to that, people sending me a message. This is some spam. Yes, block. Okay. Okay. Smartest people part of the biggest lies. Okay. Anyways, getting some bunch of messages. Yeah. Anyways, I'm showing this right here. So Mystic Bazaar is already at $5. So $5 on Hive. Yeah, 9 business. How is your computer right now? Is it much faster? And also get on Hive. You gotta get the stream. I'm getting the benefactor guy. I got him an account as well. Beneficent. So I got this guy on Hive. Maxwell sounds Freemasonist. Yeah, it's Maxwell, Jordan Maxwell. It's like what was it? Maxwell's the name of the electromagnetic equations guy. But yeah, anyways, so okay, I just created this guy's account here, and what else? Who else did we have here? Oh yeah, I think we had Iran Attila. Attila's also on Hive. Okay, and then see how much, and also make sure you can claim every 7 days. So you can claim, you have rewards you haven't claimed yet, Attila. So you should have, yeah, about like 50 cents, or actually more than that. Yeah, you posted earlier here, so you should have like a dollar, yeah, maybe $1. Okay, PC is great. Thanks. I just need a refresher course on the Hive stuff. Yeah, definitely. Yeah, we could do that. Mystic's gonna be a millionaire, like I said before. Yeah, definitely. Mystic is taking over the game. The thing is just consistency, because you have to realize Hive is not like regular social media where people go and like just whatever they want to see. Because your money and your voting is tied to the stuff you're liking. So as you're here longer, people trust you more. So when they upvote you, you're getting money. Like they're saying that you get a bigger chunk of the inflation, of the token inflation, because they like your stuff. It's not like regular social media where people just like, or you can have a bunch of bots liking and whatnot. Bots can't here. Bots liking don't do anything because their vote isn't much, because you need to actually have money tied to it. So like my post right here, yeah. So almost every single one is like at least $1. Yeah, it's like $1. Some of them $5, whatnot, and the stuff builds up and so on. And it builds up over time, especially with the token price super low. So the best time to post on Hive is literally now, because the token price is like really low, and if Hive, but even though Hive has got a whole lot of development going on, so when you're buying this one, when you're earning it from here, and then if the price does a 10x, your earnings 10x, but they also 10x from all the ones you did before. So this Hive price, yeah. So if Mystic Bazaar is at $5 and Hive price times 10, it's probably going to be, she can be at $50 around, close to there. Because he also has stablecoin. Anyways, let's continue further. I'm going to open up some stuff. I'm going to Ode. What did he say here? Actually, I was going to go over, I was going to read another email quickly. This guy here, this is because we're talking about spooks. This guy sent me a bunch of spooks stuff here. So he says, hi Matthew, I'm based in the UK and there's a ton of apparent spooks over here. Yes, indeed, Dave Von Kleist, I was going to say in the mid-2000s, very likely wouldn't have been aware of free energy use like most. However, he has no excuses today. Thanks for the links. Boston, aka 9/11 Truth. Yeah, I mean, Boston 9/11 Truth. As for Kevin Barrett, utter trash from intelligent guy. He did an interview that is on Odyssey from last month in October where he still says control emotion. A few more names I can name. You may have covered them. Correct me if I'm wrong. Charlie Vitek, a guy that had as a prominent presence in the late 2000s. One of the most bizarre characters in 9/11 cover-ups history was in a 2000 9/11 documentary. Anyways, extended was Abby Martin. Yeah, Abby Martin. Apparently, presenter and journalist. I sent a Twitter message to her in 2012 about where towers go in Hurricane Aaron specifically. She said something along, I've read it or some of it and didn't see any evidence. Okay, so Abby Martin. Abby Martin. This is a big name. I've seen some of her stuff, and she's obviously a gatekeeper. But that's those Fred videos long ago and not on social, but it resonated. I should be more active in Hive if I find more real time. I really like to finish my Hutchinson Effect article. Yeah, definitely. And also make sure to post on my thingy there. Okay, there's Abby Martin. She's got okay, so she's obviously a gatekeeper. I'm gonna go to see Judy Wood. I think she posted anything at 9/11. It's like return conspiracy 9/11 conspiracy left. Okay, so it's questioning okay, so this is the media ruins anyone who even pondering knew and allowed 9/11 to just carry out. Okay, and this is I should go to Dust 9/11. Okay, somewhat dust there, but anyways, so I want the link. Like, if you're sending some messages there, or Hurricane Aaron, So how do you how do you find anything in this? Okay, so she's all okay. So, but I want to try to find some gotcha. Is epsilon not really a constant? I'm not sure. Okay, anyways, guys, Abby's gatekeeper. She's obviously a gatekeeper. Yeah, this guy literally said I sent her in 2012. But where towers go, and then obviously covers up. Yeah, she does not have 598,000 subscribers for nothing. Luke Rondowski, yeah, so he's obviously a gatekeeper. I have included him. Nick Pope, I should include him too. Sonia Bolton, again, mystery YouTube Irish guy. Stephen Greer, yeah, Stephen Greer is a bit of a freaky guy too. Very streaky, not at Brothers. Interesting, yeah, but they're witnesses / they have the videos, and obviously, whatever. And Ian R. Craney, I'm pretty sure he was a gatekeeper. David Griffin. Anyways, there's a whole bunch of links there. What is this video? Sonia, I don't know if she's simply ignorant. However, this link shows she has Richter Gage as a guest at about 1 hour. So Sonia Bolton. Who's Sonia Bolton? Who are all these people? And she has Gage in there. Where's Gage? Oh, there's Gage. There's Gage, and he has the same nonsense. Oh, anyway, so we have a whole bunch of. It's like, how are there so many spooks everywhere? It's mind-boggling. Yeah, so we have infinite spooks, guys. Like infinite spooks. Like we're up to 70. Whitney Webb is in there. I'll include everybody. It's like I don't. Yeah, this is one of the most fascinating things. Is 9/11. It's like because it's so obvious. And then you realize, wait, there's a massive industry of every single person's a spook. And now if you guys wonder why I pushed 9/11 or even why I looked in Conspiracy Game, it's because I know, like, I only do things if I absolutely have to, because I'm like, somebody else has to be doing this. And I'm like, if nobody else is doing this, I got to do it. What was the reason for calling Abby a gatekeeper? The person who sent me an email said presenter and journalist. I sent a Twitter message to her in about 2012 about where the towers go and Hurricane Aaron specifically, and she said something along the lines, "I've read it or some of it, and it didn't see any evidence." Okay, that's a good word. I'm gonna go to Abby. And also because she hasn't said anything that's actually important. Like she's been for years and years talking about 9/11, but never any actual evidence about anything. Okay, evidence. Okay, so she maybe 2012. I'm gonna keep. We'll find this post in 2012. Okay, so about 2012, was it a reply? Okay, I've yet to see a shred of evidence that actually happened. Here. This is Thomas School. Okay, red. Whoops. So anyways, well, she's well, the biggest thing is she has a big following, yet never said anything. Anyways, I need to see what the actual thing is. Okay, didn't, read it. Okay, nothing. We go over Planck yet? No, we haven't gone over Planck yet. We're gonna go over it now, and so on. And anyways, I'll try to power through. Okay, so we're in enough of this random stuff. Just because yeah, next week I'll be in a John and Nancy's place, and we'll go over a bunch of random stuff. Okay, I'm gonna open up whatever these links are. I have opened here. Okay. This person first. I'm gonna go with cross product. This guy was asking like cross product. Okay. This later. Okay. Okay, anyways, I'll skip that one later. This person, adaptive exploration. Okay, this is some books I wanted to find it. Adaptive beamforming. No, I'm gonna just skip that. Okay, can a burning bush? Okay, this is some. Can a burning bush talk in real life? Let's see what this guy has. So apparently,
Moses.
A talking fire. Fire in a microwave. You can sustain a fireball that isn't consuming any fuel of the wood.
Okay, consider Marcus theory as we discussed phase alignment like Bethe Hitler for all matter like Russell scale. Interesting. Yeah. But again, I remember experiments. There were some experiments of Walter Russell I want to do.
Voltage field couples energy into the flame, making it burn hotter and brighter. Now inside this specific Tesla coil is an
I do want to see this. Let's see. There's a Tesla coil with a flame there.
Interrupter circuit. This interrupter small changes in pressure. But in order to perceive it as sound, it has to have some regularity to it. So if we're going to hear fire, we have to control the fire so that it heats at regular controlled intervals based on an audio signal. Fire is a partial plasma, meaning that there's a small amount of ions in the gas of the fire. So when you put
yes, the fire is a partial plasma. Interesting.
Fire near a large changing electromagnetic field, you can vibrate these ions and make even more heat, heating up the gas even more. For example, if you put fire in a microwave,
so fire in a microwave and it heats further.
You can sustain a fireball that isn't consuming any fuel of the wood. So in order to make fire that can talk, we just need to run an electromagnetic field through the fire that adds energy to it at just...
Okay, this guy's, don't show this guy's videos, you'll strike your channel, it's creepy. Yeah, but if it's in that stream where I'm talking over, it should be like a decent...
the right audible frequencies. At the base of this, I have a solid-state Tesla coil connected to a metallic candle up top. The candle's metallic wick soaks up alcohol, and when I light it, it burns with a normal flame. But when I switch on the Tesla coil, its high voltage field couples energy into the flame, making it burn hotter and brighter. Now inside this specific Tesla coil is an interrupter circuit. This interrupter
Okay, let's see. Yeah, believe Walter Russell stuff is deeply connected to your stuff. Yeah, definitely.
rapidly turns
there's again some Walter stuff I want to experiment that I want to do.
A high voltage output on and off thousands of times per second. When I feed it an audio signal through an input cable or even Bluetooth, it modulates the pulse rate of the coil to match the frequencies of the music. So this means that the Tesla coil is now pulsing the flame at the same rhythm and pitch as the audio signal. The heating and cooling of the air around the flame happen at those exact frequencies, creating pressure waves in the air that we perceive as sound. For example, I can just do a 200 Hertz sound wave and show you in slow motion. You can see that the fire is pulsing at that exact frequency. So when you see this pulsing fire, it's easy to see how that can produce an audible frequency. And some of you might have figured this out already, but the fire on top isn't necessary, because the plasma from the Tesla coil is already hot enough to make the sound waves as well. So you can just have a singing Tesla coil without the fire. It isn't as far-fetched as it originally sounded.
Okay, so anyways, you have a flame, but there's a flame on there, but I was very interested in how it increases the mumbo jumbo. Okay, anyways, we're gonna go over Planck's Planck constant. So there is a couple videos. I'm gonna open this, guys. What is this? The email here. What's this guy was talking about? Okay, yeah, this is hi folks. This is Joel, Meet Matthew, and Bob Grill. All three are doing interesting stuff. Here's Joel, or Bob Matthews. Okay, so this is I want to see Joel's YouTube. This is John Hutchison sent this to us. To me, capacitor open field. Okay, Joel, I haven't subscribed to this guy, so it's a John Hutchison like this guy. Anyways, there's just so much stuff here. We'll have to wrap my heads around everything. I'll keep that later. But I'm just gonna power through whatever has in the links, and then I'll get. Okay, this was a it's pretty interesting. But anyways, I'll do it later. Inaldino. Okay, so I'm gonna keep Inaldino stuff open. Okay, I'm gonna keep this email over here. Inaldino's. And then old stuff. What is this thing? This is from John Hutchison. Okay. Okay. Yeah. This was a recent sample that someone did a analysis in 2012 on the Hutchison effect samples. Okay. Anyways, that's for another day. I just don't have time. Okay. This is physics explained. Okay. I'm gonna close this. And close this. Okay, this guy here is the reason I did this one here is because he covered this one. What actually happens at the Planck length, and then
wondered.
But this is a pretty good channel. It's blowing up, but it's pretty good for mainstream science. And basically, and then he actually is gonna be doing some string theory stuff, which it looks like that's pretty much gonna be the new quantum mechanics, where it's gonna be mainstream. Okay, and now here's Planck units. Okay, I have this force. Okay, this is forgotten force. I'll have to watch this later. Save this for later. This was the Ampere's law. Okay, or might even do it later. Now wealth of. 1 second. I'm just gonna open up my stuff up. Okay, this is some other stuff here. Okay, that was that guy. Anyways, and now we're gonna go over Planck length. So Planck length. So let's go here. I just want to go the term Planck length. But I'm also gonna open up the Inaldino's setup here first. Because last week I was going over it and I didn't finish it because I want to finish the whole paper in here if I have time, and the landslide brought it down. Yeah, Joel Lagath is a real one, yeah. And okay, so I'm gonna go quickly over here. So this is his paper, and I'll be reading this here. So I read up to page 6 last time. Just open it. My goodness, just view it. I think I already have it earlier. I think I already have it opened. 1 second, just bear with me. I'll be more organized next time. Spectrum. This is the force thingy. I'm gonna open up in here. Okay, so I already downloaded before. Fundamentals of a theory of ether. Basically, the whole idea was how can you explain electricity without positive and negative charges? So you can go electric science without positive and negative electric charges, because those are just terms you're giving for something you don't fundamentally know. And then I'm gonna go over here. Okay. Scales for all. Okay, so this is the one here, and anyway, so Planck's constant. I'm gonna go also open up MES physics just to get an idea, and then we'll get straight into. I'm gonna go to the Inaldino stuff because I want to fully grasp it, because I think it's bombshell. Okay, the universe seems to build out everything fractal, so I wonder how valid an absolute minimum really is, considering light, matter, and frequency has no limit, divergence series. Yeah, that's where the string theory mumbo jumbo is. It's basically that limit is just the it's like the limit of like getting smaller, and then you got to go to another dimension or some mumbo jumbo. And so on. So and also I'm gonna go to Walter Russell. magnet coil experiment. This was a so he makes a ball. Yeah, this is a cool one. Conic coils experiment. You can make a ball of iron and so on. Creation of matter, gravity, CPE. Let's see what this guy says right here. I'm not talking about string theory, plasmoid unification. No, I agree, but I'm just saying the string theory is going to be the mainstream one. You have to realize there's two worlds we live in: mainstream and alt stuff, which isn't like string theory is getting like billions and billions of funding and so on. They're gonna it's similar to quantum mechanics. You gotta like read between the lines, but yeah, so that they give you the system that they want with, and then develop that. Well, basically keeps the anti-gravity stuff hidden. But you get other mainstream's bunk. Yeah, but mainstream is gonna be like what like a lot of the modern tech will be pushed on. I need to stay. Wish I could stay longer, but I need to wake up in 4 hours. Okay, Epic's up 20,000 tons. Have a good night. I'm gonna go here quickly. This is how does he do this? Okay, so he puts it here. He has a conical coils right here.
Right here, and you'll see a sphere.
This is based on the Walter Russell setup here.
Between these two.
Okay, and then if you put it in, it becomes a giant ball.
It's held together. Let's see if I can zoom in. And I'll pull these apart a little bit so you can see the tension.
And it's pulling it off. That's pretty cool.
It's about as far as I can go. So
the thing is, what would happen if it weren't conical like that?
Watch, as soon as I turn the power off, you'll see those filings fall. Kind of cool. So again, if we turn it back up. So,
okay, those are pretty interesting one. Anyways, let's continue further. So Planck's length here. So this is I want to get to the term Planck scale refers to the so this is I'll show this guy's video right here. Yeah, this guy here. What happens at the Planck length? And then basically it's like, how do you measure something? So you basically need to bounce it off and so on. Alternative media is pretty much as bad as MSM. Yeah, so it's like you have to put it together. Bye. Oh, that's 29,000 tons. Okay, have a good one. But the thing is, mainstream, they have the proofs for specific things are there. Like, for example, Planck constant and length. So those are actual measurement derived stuff from many universities at the same time, and so on. So I'm gonna go right here.
That we can keep zooming into nature. Have you ever wondered whether we can keep zooming into nature forever? Each new tool we've built has taken us deeper into that unseen world.
Figure universe is not alive. Figure out for yourself. Yeah, definitely. Yeah, you gotta. But what I'm trying to say is, mainstream is gonna produce technology. So, and like for example, everything we're using is pretty much from mainstream. Like you plug your this computer is plugged into the socket that's getting electricity from mainstream electricity in here in Richmond in Canada right here. There's a giant dam, and all it's doing is spinning a giant electromagnet. It's just spinning a giant magnet, and then that's getting current. That's creating electricity somehow. So what I'm trying to say is, the mainstream is going to go into quantum and see what other mumbo jumbos. But throughout all of that, it's kept under wraps, anti-gravity and free energy. So, but the thing is, what I'm trying to do is like, that is the name of the game. All right, the name of the game is that. It's not what theory is better, it's which one gives me what I know exists on 9/11 and Hudson effect. All our energy is operating at a fraction of capacity, so you spend money. No, I agree. That's what I'm trying to say is we need proof of like actual device. So like all the even the quantum mechanics, all this mumbo jumbo, it's all mumbo jumbo unless somebody, if I can go and plug it in, okay? I plug it in and see what happens. So that's anyways. And also the other thing is I before I usually get into alt media, I need to gain info on mainstream to see what the actual big picture is, and then see what's wrong. But yeah, no, definitely we'll go over some alt media. We'll like the Planck length. I'll show you what I think is the ether is better explanation, and so on. We'll get to this, and that's why I have the MES physics set up right here. Sparky Sweet. Okay, yeah. So anyways, let's play some stuff here.
Early microscopes revealed tiny cells and wriggling microorganisms invisible to the naked eye. Electron microscopes took us deeper still, showing individual atoms. But can we go further? Well, the answer is yes. The Large Hadron Collider at CERN is the most powerful microscope ever built. It reveals the structure of matter at scales hundreds of millions of times smaller than an atom. Yet, as we'll discover in today's video, if you keep pushing, channeling more and more energy into ever smaller regions of space, something truly remarkable happens. The very act of trying to look closer makes spacetime itself collapse, creating a black hole. And this suggests an operational limit to our most successful theories, a sign that something new is needed, perhaps a framework like string theory, which posits tiny one-dimensional vibrating strings as the fundamental building blocks of nature. But to understand where these boundaries lie, let's start with a simpler question. How do we see the world around us in the first place? Well, in order to see something, we need to scatter light off it. This requires three ingredients: a light source, the object itself, and a detector like your eye. Then the light from the source can scatter off the object and into the detector. Roughly speaking, the smallest detail we can resolve depends on the wavelength of the light we use. There's a simple rule of thumb. We can only resolve a feature if the wavelength of the light is roughly the same size or smaller than that feature. It's a bit like a ship on the ocean. If the wavelength is much bigger than the ship, the water rises and falls almost uniformly across the hull, so the ship mostly rides up and down and the wave barely notices it. But when the waves are comparable to or shorter than the ship, they scatter and reflect strongly from the hull. Okay, so imagine we want to shine light onto an object and resolve a feature of size delta x. We therefore need light whose wavelength lambda is roughly less than or equal to delta x. So far, so good. But at the beginning of the 20th century, Albert Einstein made a profound discovery. He realised that a beam of light actually consists of a stream of tiny fundamental particles called photons, and this allowed him to explain the photoelectric effect.
Yeah, this is where I have a big part right here. It's been known a long time since NP phase alignment sub-analysis to make multi-frequency brainwash everyone with condensation. When it's band gap. Okay, anyways, just slow down. But yeah, so anyways, so this is the part here, and this is where I want to diverge from the Planck line just to illustrate. So he's saying that it's quantized. These are actually like it's actually just wrong. Like this part is just there's just no way around it. It's just, but the numbers like again the mainstream numbers are still correct. But just the interpretation is way off, and that is from going right here. So Planck's constant. So, and now this is where, and we'll go over to the photoelectric effect, because he's saying that it was quantized, and the way they do it is this. I'll show the notes right here, hide notes. So the way...
In classical mechanics, the energy of light...
So the way they quantize mumbo jumbos is, so if you have a, they have, basically have, this is Planck's constant. They call the quantum of action, and what ends up happening is, so they have energy, which is given in units of joules second. But what actually happens is, yeah. So this, for example, this is a bug. This frequency, yeah, because you have, yeah, this is HS. Because basically what they do is they ignore that the frequency term. Oh no, this energy is H. Yeah, so energy is H. And then this one is. I'm trying to wrap my head around. Yeah, so basically, in mainstream, the quantum stuff, what they do is, when they say that each frequency of light has its own quantum of light, a quantum of energy, what's actually, or a photon, what they're actually doing is they're taking a frequency of light for one whole second, and then saying that's a unique fundamental particle. But I'm like, but the second is arbitrary. So we'll go back right here, and I'm contemplating just playing the whole thing. Yeah, so I'll play the whole thing here just to illustrate it. Right here. So in classical mechanics, the energy of light is continuous, but this doesn't always make it. This is classical. Explain.
In classical mechanics, the energy of light is continuous, but this doesn't always match observation. In quantum mechanics, energy can only take on discrete values, however, the units are unbalanced.
E equals h over t, since F equals 1 over t, so is it h or t that changes to change energy? Or both? Well, no, t is arbitrary time. Like, what is the actual time? And so if you're doing or both, yeah, basically what's happening is, so h is a constant that you correlate energy to the frequency. Yeah, but the frequency has a thing called a unit called, and also frequency is not 1 over t. It's cycle over time. It's the actual one cycle. It's not a 1. So 1 is just an arbitrary number. So in quantum mechanics, energy can only take discrete values, however the units are unbalanced. And they're unbalanced because you have a delta that's ignored in here.
The equation E equals h times F is Planck's energy frequency relation and is the energy of a single quantum of light called a, quote, photon. In Fractal Woman's modified unit analysis, balancing the units of the Planck relation formula reveals a minimum unit of energy.
Yeah, so basically what I'm trying to say is this. So if you have a big wavelength right here of light, in mainstream physics, they would say, and this is 1 unit of time, so let's say you had a second. So in 1 whole second, that is the photon. But there's clearly like a bunch of wiggles in there. So how can you have a wiggle? That's a bunch of photons there. And that's for 1 second of time. And if you have a smaller one, you have more of these wiggles, and they'll say this is higher energy. And if you have like a gamma ray, super many wiggles. But you could reinterpret it as the actual each separate unit as one Planck's constant of energy. So if that's one energy, and they're all exact same energies, higher gamma, higher wave, a higher wavelength or lower frequency just has less energy because there's less energy units. That's it. There's nothing else special about it. There's no, you don't have a million zillion quantums.
In quantum mechanics, the energy of a, quote, photon is quantized by the following equation. E equals hf, where E is the energy, h is the Planck's constant, and f is the frequency of light. Frequency is the number of cycles or oscillations per unit time. The international standard or SI unit for frequency is Hertz, which has base units of 1 over second or second to the power of -1. A pendulum is shown making 25 complete oscillations in 60 seconds, which gives a frequency of 0.416 Hertz.
And also notice here, so mainstream it says, so it's a Hertz. It's cycle per second, CPS, revolution per minute, RPM. But then SI, they're all they're doing is second to the power -1 or 1 over second. But that's not what it is. It's not time to the power of 1. It's saying it's 1 over time. But you're ignoring the cycle. Where's the cycle?
The Planck constant is referred to as the quantum of action and is associated with the quantum or minimal element of the energy to the electromagnetic
wave. So mainstream it says quantum of action. What in the world does that mean?
Wave. In SI units, its value is 6.626 times 10 to the power of -34 joules per hertz or joules second.
Yeah, so basically joules second. So what it actually is in mainstream, they're giving Planck's constant as the energy in 1 second. Okay, joule second. It's the energy of 1 second of it's energy. No, it's per 1 second. So it's energy. It's like an integral. Basically, it's the energy over 1 second. But it's not associated to any frequency. So and so then that's what they're saying. So that's a quantum action. So it's the energy of 1 second of nothing. Of literally just says that you have to multiply the frequency by. That's all it is. So it's actually an imaginary thing.
When Planck's constant is written in units of joules per hertz, the energy equation is balanced. However, if Planck's constant is written in units of joules second, the energy equation is unbalanced since there is a hidden unit of, quote, 1 remaining.
Yeah, so basically, yeah, so if you have frequencies in terms of hertz, all right? And then this one is energy per hertz, so energy per frequency. Then these would cancel out and you have joule. But if you remove that hertz and then instead you deal with seconds, so it's a joule second, and then this one is 1/2. But where's the cycle? So now you have a j times 1. So you can't just ignore this 1. Okay, it's something divided by that.
In fractal,
as frequency goes up faster, dE over dt drives higher displacement current density. Okay, generally, yeah.
Woman's modified unit analysis.
It's basically vibration. It's a higher frequency, higher vibration. That's it. So in fractal Woman, all you do is include the delta, include the cycle, so a full cycle of time.
The unit of cycles
a cycle wave. Okay.
Accounted for using the delta or triangle symbol instead of ignored using the number 1. Thus, Planck's constant has units joule times second divided by cycles, and the energy equation is balanced. Accounting for the units of cycles reveals that Planck's constant can be interpreted as being the energy of 1 cycle multiplied by 1 second. The term 1 second appears to be an arbitrary construct. Since 1 cycle of an electromagnetic wave is just its wavelength, this means Planck's constant is equivalent to the energy of 1 cycle or wavelength multiplied by 1 second.
Yeah, so that's basically what it is. So and this is mainstream. Planck's constant is equivalent to the energy of 1 cycle or wavelength multiplied by 1 second. So you have energy. This is per 1 cycle. Remember, it's in hertz. So this is going to be divided by hertz. So it's going to be divided by cycle per second. So basically, yeah, Fractal makes valid points. Yeah, no, it's not just valid. It's literally just better. It's just there's no other way around it, in my humble opinion. Like the mainstream is literally just adding completely unnecessary mumbo jumbos to it. It's so simple that makes quantum mechanics just actually understandable. So, anyways, keep going. So,
if we decouple the unit of time from Planck's constant, the energy equation becomes modified Planck's constant multiplied by time and frequency. This new Planck's constant has units of joules per cycle and is equivalent to the energy of 1 cycle or 1 wavelength.
Yeah, so instead of just using just one there, put a T. So now you have you actually understand what it is. This is the energy of 1 cycle. Times it by 1 second, and then times it by the actual frequency, which is the number of cycles per second. So that you cancel this out. Now you're left with the total energy in 1 second. And
this new Planck's constant, indicated by the subscript delta, can be interpreted as the quantum of energy. The energy equation now becomes the quantum of energy multiplied by time and frequency. Higher frequency of light has more energy because it contains more cycles and hence more quanta of energy per 1 unit of time. And vice versa, lower frequency light has less energy because it contains less quanta of energy per time. Higher frequency light has higher intensity because the same quantum of energy strikes a detector at a smaller area and for a shorter period of time.
And then the photoelectric effect is basically you have light hitting metal and then electrons fall off. That's because the higher frequency, and it depends on the frequency. This has to hit it, and then so it doesn't matter how much of this you put in there. It's kind of like let's say if you have a hose, and if you have some water going in, but if you had a bigger hose, you can't brush something off that script on the ground unless you have something super tiny. That's why they have the jets that are like the water jets that are super tiny. So basically, you're packing in a whole lot of these inside. Anyways, something like that.
In quantum mechanics, Planck's constant is referred to as the quantum of action. Each light frequency is comprised of a different quantum of energy called a, quote, photon.
Yeah, so basically what they've done is they put multiple quantum. So they give an imaginary quantum of action, which doesn't actually do anything, like meaning anything, that needs to be multiplied by every frequency, just so that every single photon has every single frequency has its own associated photon. But frequency can alter slightly. So you can have something slow frequency, high frequency, and then basically at any single one, you're just saying, and then multiply by h, now you have its own photon. So you have infinite amount of photons, which doesn't make any sense. As opposed to just one quantum of energy, and then that's it. Yeah, one quantum of energy, and you can describe the exact same thing as a mainstream. And and it's different frequency just means different energy levels. That's it.
The term S, or 1 second, inside the units of Planck's constant is a bug. In Fractal Woman's modified unit analysis, this bug is fixed by decoupling the time parameter from Planck's constant. This new Planck's constant is the minimum energy or quantum of energy. Every light frequency is made up of the same quantum of energy. To reiterate...
so here's I made an Excel file. And so you have gamma rays, they have a specific frequency, specific wavelength, and then the energy is going to be, each one's going to be a photon. So you have to say a gamma ray has frequency multiplied by this action constant, and they have its own photon. So you have a photon of this one here, this photon. So then, and if you have anything in between, because again, there's like a spectrum, you can have just infinite amount of photons. Does that make any sense to anybody? So Planck's constant, quantum of energy, is it, and quantum mechanics. This is modified unit analysis by Fractal Woman. And then if you go to quantum mechanics, you have infinite quanta of energy as opposed to just one. You can describe the exact same thing, but just using one quantum, not quanta. Okay, and Planck's constant, that's using this setup with a joule second. And again, all it is multiplying by 1 full second.
In modified unit analysis, all light is made up of one quantum of energy and whose value is 6.26 times 10 to the power of negative 34 joules per cycle. In quantum mechanics, there are an infinite number of quanta of energy obtained by multiplying an infinite range of frequencies by the quantum of action.
You can have infinite frequency that has no limit to scale, like I said. But in this one is I think it's of measurement. You can't measure anything smaller. But also, according to quantum mechanics, you can't actually get super tiny. It would be like a black hole. I guess limit is the universe itself. No, yeah, but the quantum mechanics one, if you look at that guy's proof, he does it from 2 different angles, and they get the exact same thing where the numbers match up. So it's pretty much, I think, to measure super tiny, you need infinite energy, and that creates a black hole. And in other words, so that's the fractal part. So there's a black hole to tiny, and then black hole, which again I think is just a magnet. But anyways, let's keep going.
6.26 times 10 to the negative 34 joules times second per cycle.
Okay, yeah, and now Fractal Woman's actually working on a paper right here. That's rethinking that, and she's getting it reviewed by this guy, Dr. Wimpin Young, and basically it was rethinking the photon motivation of sound movie, and then basically she using help with ChatGPT, and basically using power instead. So they're both correct. It's just different ways of looking at it, because again the mainstream setup, the energy equation. It's like basically you're taking it, it's a total energy associated with an oscillation frequency basically over a second. The total energy over a second, and then power view is basically energy flow per cycle of oscillation. I think basically as the per cycle, basically it's the same thing I was talking about. Quantum of action versus quantum of power per cycle, just different setup there. That's energy per second. Anyways, that's that part. I think she has a paper coming up. See the paper here. Cycles a fundamental unit of angular measure. Where is I think she has a paper.
When the angle is
and then this is her paper that she's working on. So cycles as a fundamental unit of oscillation manifesto for cycle-based system. Yeah, so that's the thing. Cycle is literally the fundamental thing. And then basically what the question is, can you go smaller and smaller cycles? And even if you can you measure it? So like, you know how you're saying you can have infinite frequency. Yeah, but you're talking about infinite. Well, how do you get to infinite? And the question, can you measure it? And what is the actual closest thing they can ever measure? And then are they able to get it smaller and smaller, or are you able? So we'll go to the mainstream. Okay, so anyways, but the thing is, every time I go there, we have to keep going. Now we got to go to the I know the new phase here, right here, because he's saying that photons is what causes photoelectric effect. So I might do a video separate on this, and actually a photoelectric effect. Yeah, maybe for another one, but I do want to power through the thingy, photoelectric effect. This is the mainstream setup here. Photoelectric for metal plate accompanied by absorption of light quanta. So basically, you need a specific, you need high enough frequency to hit this so that it falls off. Ultras are oscillate in the presence of a magnetic field. All it takes is the presence of 2 or more bodies in space to make magnetic field of cross E field. Okay, anyways, I'm not sure exactly what you mean, but we'll get to the photoelectric effect where even explain that with the gravitational waves. It's like these are gravitational, electrogravitational, according to Einstein knew. But anyway, so if you have photoelectric effect, basically to get the charges off, you need a high enough frequency with light there. So if you can see right here, this is the spectrum. So diagram of maximum kinetic energy is a function of frequency of light on zinc. So you're not going to have anything pop up until you get to higher frequencies, and that's pretty much. Yeah, but that's the same thing as you can explain it. The same thing with the photon setup. Simple as band gaps. Band gaps explain Casimir effect. I'm not sure what band gaps are. Asymmetrical light pressure. Yeah, that could be it. They're all just ether sound. But anyways, so there's multiple things of explaining versus like experimenting. And also that MES physics one again. Fractal the isopotential lines. Let it explain paradox. Faraday paradox and Stern-Gerlach experiment. Anyways, so now, so that's photoelectric effect. And why is the guy eating a thingy here? Okay, this is Ampere's law. We'll keep that for later, maybe. That's pretty interesting, though. I'm getting a likely fraud. Okay. Yeah, this is fascinating stuff here. So, like, okay, so anyway, so he's saying that photons are the reason why electrons can be knocked off by light at only high frequencies. So at low frequencies doesn't do it because it's photons. So basically it's saying you can't have just an infinite amount of low energy light to knock off thing. You need a high enough frequency. But in other words, you just need the high enough frequency. That's it, and nothing else. It's just the fractal Woman setup there. You just need this. You just need high. You need enough of the. It's like a jet. You're not gonna be able to do that unless you have a super fast jet there to knock stuff off. And again, just water jet. Okay, so again, in my opinion, it's just very, very extremely simple. There's nothing else to that. Okay, and now I'm going to go to I know D news. I'm going to read from the beginning again, I know D news, because I was doing it last time. Actually, we'll just keep reading from here. So if you haven't seen my last stream, I went over this one, Fundamentals of Theory of Ether. So the introduction, basically he was saying that, yeah, he thinks he solved it by light as electrogravitational, not electromagnetic. So I'm going to keep going here. So the Evufuelin and the 2000-year problem of explaining electrostatics mechanically. Have you ever wondered how? And what is this one here? Search pre-search. What is Evufuelin? What in the world is going on here? Is a scalp disorder characterized by thinning or shredding hair loss? No way. Is it hair loss? The photons and electrons are coupled. Lead Dr. Brendan's work explaining entanglement Hall effect. Anyways, you're ahead of me in this stuff. I'm not as well versed as you. I'll just go very, very simple and see what happens. So this guy here, this is I know Dino because I'm pretty sure he's right. And again, I like mechanically explaining everything. Have you ever wondered how scientists who observed and wrote about electric phenomenon since Planck almost 2,000 years ago have actually attempted to explain what they were seeing? They were all, without exceptions, discussing the effluvium, or emanation, a type of fluid that electrical objects seem to emit in all directions. The altermagnetic field collapses, making topological monopoles. Merca generators can be driven. Anyways, yeah, that's a bit of word salad. Get me some experiments that you've done, and I'll play them again. Because my goal is this: what I'm trying to put theory into practice, like actually get something that's showing as opposed to writing words. Okay, and then basically the previous ones were talking about emanation of a fluid coming from the electric substances. For how else could the electric object act on another object at a distance away from it? Of course, this fluid was invisible, but the idea of effluvium, basically ether, was important because it was employed to give a mechanical explanation of the attractions that were observed. Initially, it was believed that the effluvium displaced the air around the charged object, and that the air pressure imbalance thus created force any nearby objects towards the charged particle. Later, when the same interactions were observed by Robert Boyle to take place in vacuum, it became clear that it was not the air, but the ether that played a role in the observed interactions. Since ether was believed to remain in the space of Torricellian vacuum, unsurprisingly, the author of the Three Laws of Mechanics, Isaac Newton, attempted a mechanical explanation of the electrostatic attraction with the help of an elastic fluid. So basically, I'm doing this as I think it's inelastic, emitted by the electric object. So excited rod attracting light bodies. Macomopole generated out of benzene type structure like barium titanate makes to amplify magnetron beam. Okay, epic stuff there. Barium titanate. I wanna grab that up. John Hodgson when I visit him. he has one that he values very highly. It's incredible as it may seem, more than 100 years had passed between the first scientific investigation of electricity by Gilbert in 1600 and that of electrostatic repulsion by Gray and Dufay in 1733. So more than 100 years had passed between the first investigation of electricity and that of electrostatic repulsion. Thus, it can be said that proper study of electrostatic repulsion has been overlooked for about 16 centuries. It was more than 100 years had passed. Basically, we said that proper study of electrostatic repulsion has been overlooked for about 16 centuries. If we count since the time of Plutarch in the year 1000 AD, when people attempted their first explanation of the electrostatic force, Benjamin Franklin, in spite of his extensive researches in electricity, was perplexed when he learned that electrostatic repulsion existed between two bodies resonantly electrified. Electrostatic repulsion was difficult to explain in a science whose name, electricity, entered the English name as a power to attract straws or light bodies. Because if you basically, excited rod attracts light bodies, but basically you have electrostatic force, it's grabbing it. But then if you have repulsion, okay, the science of electricity has had a complicated development, and one of the reasons for this complication was Dufay's introduction of the idea of the existence of two kinds of electricity to explain electrostatic repulsion. It can be said that Dufay's introduction to the idea of existence of two kinds of electricity almost put an end to the whole effort of finding a mechanical explanation of the electrostatic interactions, because his view implied that two kinds of electricity acted on one at another at a distance. Basically, that's a positive negative charge. That kind of ruins pretty much everything, and I fully agree with that. To make matters worse, the concept of effluent seemed to give contradictory explanations in the case of electrostatic repulsion. For how to explain repulsion between two electrical objects if they both emit, and especially if they both absorb effluvium. Effluvium is nevertheless an important concept to return and consider, because it is a healthy scientific concept being derived from a healthy and legitimate way of scientific reasoning, something that the experimenters of the past worked so much with in their effort to find a mechanical explanation of electrostatic interactions. And effluvium is I'll put this, is relevant because it naturally led to the development of the theory advanced in this work, which theory, however, makes no use of effluvium at all. How is this possible? First, effluvium is heavy-sized one-part dipole. Anyways, Sirius is the other. Yeah, you're all over the place. I'm just trying to slow down. Basically, what I'm trying to say is, what in the world is an electric charge, and then demonstrate it in 500 different ways, in mechanically, physically, theoretically, mathematically, what it actually is, and then go from there. Because I'm pretty sure this guy is the starting point. I think he's right, and which I will try to do replication experiments. So first, effluent is related to the fact that electrostatic charge is a short-range force, unlike the gravitational force, which acts through the vast distances of the interplanetary space. So this is different from gravitational. Gravitational goes fastest when it's short-term. So although both forces act through the ether, they are not similar because they do not act through the same mechanism. The gravitational force was identified in I9, interesting, 9/11 backwards, as a buoyancy force in the ether pressure gradient necessary for its action being produced by the total radiation emitted by a star or planet. The short-range feature of electrostatic force is very well documented, or very well captured in the concept of effluvium, because effluvium as something emitted by the charged object cannot be expected to travel too far through the ether from an object that emitted. However, it is not reasonable to admit that the charged object emits effluvium continuously, because this would mean that the charged object is an infinite source of effluvium. It follows then that the effluvium emitted by a charged object must return back to the charged object that emitted it, which is what some investigators in the past actually believed it occurred. And if the effluvium is emitted, then it returns back, then it is emitted again, then it returns back, and so on. We have a to and fro motion of effluvium that originates at the charged object. If that is the case, then there's no need for effluvium at all, since the same function can be assigned to the ether surrounding a charged object. Taking a charged object as an object in molecular vibration immersed in ether, it can be seen that the ether will be pushed to and fro by the charged object, and that this to and fro motion will act on the object placed at a distance. Thus, what we call an object with electric charge is in fact an object charged with energy of vibration. So basically, the charge is a vibration of the ether. According to this, this naturally leads to the conclusion that what we call the electrostatic fields surrounding a charged object is in fact, this sounds like Bob Ginner talked about, interesting. This naturally leads to the conclusion that what we call the electric field surrounding a charged object is in fact a to and fro motion of the ether produced by vibrations of the object. We have seen in II-10 that attractions and repulsions take place between vibrating objects immersed in a liquid, and we will see later that how the laws of electrostatics can be explained by the coupling of vibrating objects acting on one another through the ether. So the experimental background of the laws of electrostatics, how the electric charges were invented, a digression into the atomic structure. So what exactly are the electrostatic phenomena that any theory of electrostatics should be able to explain? The list of 6 electrostatic phenomena below is the most comprehensive due to the inclusion of the last item. So basically, electrostatic phenomena, any theory needs to explain all these. And I need to go to the washroom quickly. I'll be back. And we will get to basically this is photoelectric is photons. Effluvium and unpleasant, harmful odor, secretion, or discharge. Yeah, that was initially they're saying is like a discharge of it. And I'll be back. I want to play a video while I'm going. I'll just play this one here. Again, just to illustrate, this is Einol Dinu. He's the one who set up this setup as well. The theory. I mean, basically rotating magnets behave like... rotating cylinders behave like magnets. I'm going to play this while I go to the washroom. I'll be back. Just to grasp it. It's, again, pretty wild. I need a definition. Okay.
Here we have 2 identical cylinders completely submerged in water and connected by 2 flexible hoses to 2 identical electric motors. The electric motors will be driven by a common 12 volts car battery. In this experiment, we're going to start the motors, which are going to rotate the cylinders in opposite directions. Let's see what happens. We start the motors now. We see that the cylinders attract each other and now are sticking to each other. Let's try to separate them. Oh, we see them attracting each other again and sticking to each other. Let's stop the motors. We observe that the cylinders are coming back to their original positions. In this experiment, we're going to rotate the cylinders in the same direction and see what happens. Let's start the motors now. We observe that the cylinders repel each other. Their relative distance is increasing. Let's try to push them against each other and see if we can reduce the distance. And what happens if we reduce the distance? Well, it's quite difficult to make them approach each other. We see that there is a force.
Alright, anyways, you guys saw that. It's pretty epic stuff here. And again, I can't stress this enough. You have just spinning cylinders behave like magnets, okay? And then just modified properties a tiny bit, and you got electromagnetism. Like, it's just very, very straightforward in my humble opinion.
Like poles repel, and the same behavior is observed for both the cylinders and magnets.
Again, this is they behave the exact same setup there, and they all move towards
even when placed.
Even if you play opposite, it flips over anyways. So that's that. We have 30 minutes left. I want to get I want to keep reading, but the thing is, I want to keep reading this, but I also want to, because the title was Planck's length. We'll get to again mainstream as we'll just play a bit more.
Called photons.
We'll go back to the we'll just flip back and forth between this. I'll do this. I'll pretty much do this in every Wednesday stream. And basically flip back and forth between this and then the other one. Definitely oversimplification, but quite nicely done. Yeah, definitely. But like the idea is there, is like it's a mechanical demonstration of this, and then now it's like that's just again. It's like this is so mind-boggling. It's an oversimplification, but I think it's not that much of a simplification. I think it's just that water water is just too sticky, and so on. So you need something with zero friction, according to his theory. And anyways, we'll go back into okay. So we have this. So we need to basically get all of these. Basically explain all of these in a theory, and yeah. And I want to get him on a show one time. He said he just didn't want to do it. But anyways, we'll play here. We'll go back into Planck's length, and now so this guy derives it mathematically, the mainstream mathematic, from two different ways, showing that there is a limit to how much can be measured, based on I think black holes or mumbo jumbo.
And this allowed him to explain the photoelectric effect.
So anyways, photoelectric effect is just the frequency of the energy. Like they're just higher intensity. So in 1 second, you're gonna have higher vibration. So it's like just water jet. You can't just, or not just a water jet, but actually it could be like water jet or something else. There's different fluid tests or just in water. Different fluids will have different behaviors, but like if you have you gotta have a super solid one. But water, he did one and only water. But the idea is there. And the thing is, water you have vibrate too. You can also replicate just similar replications of ether waves, and so on. But anyways, any kind of fluid you could have similar setups. I would believe. I wanted to do one with air. Air would be a cool one. But anyways,
Einstein realized that each photon,
I actually tried to do it with air. It was just very hard to do.
Must have a well-defined momentum and energy, which we can calculate if we know the wavelength lambda of the light, along with Planck's constant, which has a tiny value of 6.63 times 10 to the minus 34 joule seconds.
This means see that joule seconds. So basically, it's like an action over a it's like energy over a second. But it's not per second. It's like an energy and a second. So it's like you don't know what the length is. So it's all completely out of whack. Anyways, we'll go back here.
Seconds. This means that if we wish to resolve details of size delta x, we need photons with a wavelength at least comparable to this size, which implies a photon with energy roughly equal to hc divided by delta x. And this...
Yeah, so basically what they're saying is to measure this, you need a photon that small. You need light that small to measure something super small. But to compact light, you literally need to go to infinitely small frequency. But but also what you also the energy is correlate. Energy increases exponentially with it.
This tells us something profound: that to see smaller things, we need light with higher energy, and this is because shorter wavelength light corresponds to higher energy photons.
Yeah, but it's just higher energy compacted. In other words, with the fractal element set up there. Basically, there's more energy units into a little space. So if you're compacting that into an infinitely small size, you literally have infinite energy skyrocketing. You got a black hole, and so on.
Now, because visible light has wavelengths around half a micrometer, visible light can be used to resolve things like hairs and cells, but not atoms. Even the best optical microscopes are diffraction limited to about 200 nanometers. And so the reason we cannot see individual atoms with sizes of around 0.1 nanometers is because visible light has a wavelength that is thousands of times larger than the size of an atom. And so if we wanted to resolve individual atoms, we would need wavelengths comparable to or smaller than the atoms themselves. That's why X-rays with wavelengths of around 0.1 nanometers can reveal individual molecules and even the atomic structure of crystals. Now, one of the great discoveries of the early 20th century was that not only light, but all matter behaves like waves. Louis de Broglie showed that every particle of matter, electrons, protons, even whole atoms and molecules, has an associated wavelength given by exactly the same relation as for photons, lambda equals h divided by p, where p is the momentum and h is Planck's constant. And so matter itself can act as a kind of wave. This means that we can use particles like electrons as probes to see small structures, applying the same logic that we used for light. The shorter the de Broglie wavelength, the finer the details that we can resolve. So let's consider an example.
Anyways, he goes through some examples here. But yeah, basically, I think with electrons and then making it similar to, but using the wave-like behavior of an electron and so on. I think it's from here.
Around 0.1 nanometers. And this is precisely what happened in 1927 when Davison and Germer fired a beam of electrons towards a nickel crystal and observed a diffraction pattern, confirming de Broglie's matter wave hypothesis.
And
now
I think what they do is they send like, do they actually send electrons like super giant? Yeah, so they fire electrons. Yeah, so they fire electrons in the Large Hadron Collider at like infinitely fast
energies that experiments at the Stanford Linear Accelerator Center, SLAC, in California, beginning in 1967, first revealed that the proton has internal structure. By firing electrons with energies of up to around 20 gigaelectronvolts at hydrogen and deuterium, researchers observed that the electrons scattered from point-like constituents inside the proton. These constituent components are known as quarks. And these deep inelastic scattering experiments earned Friedman, Kendall and Taylor.
Yes, I know. So they would fire it at they need like infinitely long setups there just so they can get high speeds. But to get if you see the numbers right here, I think he says so. Like how big of an like to get past the Planck's or to just to measure the Planck's constant. Pertium is pure toroidal moment. Yeah, interesting. But like just to illustrate the amount of energy in the mainstream setup there. This is, I think he says kilometers or km. I think, yeah. So the Large Hadron Collider to get the energy enough to what it's currently doing, and then versus how much you need just to get to the Planck's length, like to get to this to measure this one according to mainstream physics, you need the wavelength to be proportional to it. So you'll need, let's see how big the Large Hadron Collider needs to be able to measure Planck's length, just to illustrate the amount of energy we're talking about. Why they say there is a limit in just at least mainstream terms.
If you take the LHC, it accelerates protons around a 27-kilometer ring, with each proton reaching energies of around 7 TeV.
So that's I think 1 trillion electron volts.
So let's imagine
that's like an electron volt. I think it's a energy of 1 electron excited by 1 volt or something, or something like that.
Simply scaling this up. Then to reach the Planck energy, we would need to increase the energy by a factor of approximately 10 to the power of 15. And so if we scale the LHC's circumference by this same amount, we end up with a circumference of around 4 times 10 to the power of 16 kilometers, which is roughly 4,000 light years. That's hundreds of times larger than our entire solar system, and a few percent of the size of an entire galaxy. An almost unimaginably vast scale.
Okay, yeah. So just give me an idea. So according to mainstream physics, the biggest telescope or the biggest microscope in mainstream physics is Large Hadron Collider or something like that, around 27 kilometers like long, because you need to get it super tiny, and then you just measure reflection or something like that. Anyways, to get the equivalent, just to get to the Planck's length, Planck's energy scale, you need 4,000 light years distance. Okay, so that's 4 times 10 to the 16. So you need bigger than the solar system, hundreds of times larger than our entire solar system. So again, that's why they're saying that's the level, the number you can't get closer to. So when you're saying it's an infinite frequencies, yeah, but like, what do you mean infinitely small? Like, how are you going to measure it ever? So according to mainstream physics, to measure it, you would need this much energy using the current techniques of measurement.
Vast scale. And so we see that the Planck scale is not merely beyond today's technology, it's beyond any conceivable accelerator that resembles the machines we build today. But more importantly, it marks a fundamental boundary in what is operationally meaningful in physics. The analysis we've just carried out tells us that there is no possible way, even in principle, to probe distances shorter than the Planck length. Any attempt to do so would concentrate enough energy to create a black hole, hiding the very region of space we were trying to observe. But the most striking thing is that this same limitation, the impossibility of probing distances smaller than
beta nuclear interactions or neutrons may be of use here. Yeah, but anything. Yeah, so this is where you need exotic techniques and so on, or they're probably doing some occult. Just tell us what the numbers, some occult ritual magic. So, anyways,
the Planck length can be uncovered from an entirely different line of reasoning, one that extends one of the foundational cornerstones of quantum mechanics, the Heisenberg uncertainty principle.
Oh yeah, this another part is so basically the first principle is they use is black hole science, and then they said okay, if you have enough energy, you'll create a black hole, and then the other part is like if you know like basically the closer you are to this, the actual amount of momentum is going to become harder and harder to find out, and what ends up happening is like as you try to measure smaller and smaller, your accuracy gets actually at a point where it starts diverging. So you actually can't measure according to their setup there. At least use Dr. Rife microscope, FBI, yeah. That'd be good to check it out because again, you gotta make sure alt media again like you have to like make sure everything is onto something. Okay, I just want to go here. This is per. So what he says is from two completely different ones, you get the Planck length right here. And so from black hole collapse and generalized uncertainty principle, you can get the exact same numbers here.
And this result is truly remarkable. From two completely different arguments, one involving black hole collapse, the other rooted in quantum measurement and the generalized uncertainty principle, we reach the same conclusion. There exists a smallest meaningful length in nature, the Planck length. Below this scale, the very concept of distance, and with it the classical notion of space-time, ceases to have operational meaning.
And this is stems from, I think I should go to the chart. You can watch this video later. I might do one on it, but because I want to focus more on the I know you knew until I grasp it fully. But is what ends up happening is according to a generalized uncertainty principle is as you get closer, the momentum is diverging. And I think the momentum is associated with energy. So as you get higher energy, it's gonna be a divergence. So this is where you're trying to measure right here.
Red line shows the new gravitational term, whereby increasing the momentum uncertainty increases the positional uncertainty. And then finally the blue line shows the combined effect. And we clearly see that there exists a minimum possible uncertainty. The effect of the new term is to halt the decrease in delta x as delta p increases, and then actually cause it to rise. To find the minimum delta x...
And then basically, yes, to measure the small one, you need high energy or high momentum. And then at a certain point, the uncertainty actually increases. So basically, this is a minimum point. And then what's interesting is from two different frameworks, you get the exact same number from the black hole science and from this one. So again, mainstream physics, whatever you say about it, it's still it's cohesive. Like it lines up with itself. There's not gonna be this giant gap in there. So it's like basically, so it is correct in the framework it is, but it's ignoring certain things, which is ether and free energy and anti-gravity being existing. Anyways, now this is where they talk about string theory, because I think string theory is gonna be the one that's being pushed as the new quantum mechanics. It's gonna be a bit wild. Let's see what.
Let's put them on equal footing. The classical notion of space-time ceases to have operational meaning. So where does that leave us? Well, we appear to have reached an operational boundary. To see smaller, we must use higher energy, but near the Planck scale, the attempt backfires. General relativity predicts collapse into a black hole, while the generalized uncertainty principle shows that delta x stops shrinking and starts to grow. It's not that quantum mechanics or relativity are wrong, it's that at Planckian scales, quantum effects and gravity have to be treated together. Any viable theory must put them on equal footing. One such idea is string theory. It suggests that the fundamental building blocks are tiny one-dimensional strings with a finite size, of the same order as the Planck length. That finite size changes the rules. Pushing to higher energy doesn't sharpen your view, it excites more vibrational modes, and the effective extent of the string spreads.
That's an interesting term there. Okay, so because I think this is something I don't know, just seems very interesting. So as you get higher energy at this this Planckian scale, what ends up happening is you just get a different vibrational node. So you get a minimum scale, but then now you have a different vibration. So again, that's what this whole
vibrational modes.
A whole string theory. And again, I think this could also line up with ether mumbo jumbos too.
And the effective extent of the string spreads. The string's size therefore builds in a natural limit to resolution. What's remarkable is that string theory starts out as a quantum theory of vibrating strings, but when you zoom out and look at it from afar, the equations of Einstein's general theory of relativity naturally fall out. Gravity isn't added in by hand, it's already there, hidden in the theory itself. And it even contains its own string version of the uncertainty principle, which closely mirrors the generalized uncertainty principle we derived earlier. In both, the first term is the familiar Heisenberg relation, and the second grows with momentum. When they balance, delta x reaches a minimum. In string theory, that minimum is of order the string length, and in the GUP from earlier, it's of order the Planck length. Either way, nature refuses to let us probe beyond that fundamental scale. Loop quantum gravity takes a different route. Instead of introducing extended probes, it quantizes spacetime itself. Its fundamental states are called spin networks, webs of nodes and links that represent quanta of space, with the links corresponding to discrete areas and the nodes to discrete volumes. In this picture, space is built from indivisible chunks roughly the size of the Planck scale, and beneath that, the smooth fabric of spacetime gives way to a granular quantum geometry. Both string theory and loop quantum gravity are active programs of research with real successes, real challenges, and real open questions, and I'll take a deep dive into both theories in the near future. But for now, I'll leave you with the words of Nima Akani Hamed, who says, "Every time we've encountered ideas in physics that cannot even in principle be observed, we have come to see such ideas as approximate notions. However, this instance is particularly disturbing because the notion that emerges as approximate is that of spacetime itself."
Oh yeah, so it's pretty wild stuff there. But again, this is one of the best mainstream physics people. Again, 9/11 and also my gyro experiments means. I'll summarize this one. I'll put a link there, and I'll continue. Yeah, that's pretty. I'll ask Grok quickly about stuff. I just make a table. Go to Grok. Make a table explaining Planck length and why we can't measure past it. And what else is it? And and the different methods of deriving it, and the possible theories for explaining or describing Planck scales, such as what's it called? Theory, etc. Okay, let's see what happens here. Okay, let's see what Grok says. Planck length is a natural unit of length in quantum gravity, defined as this. Reduce Planck's quantum. Okay, why we can't measure below it? Heisenberg uncertainty plus gravity to probe a distance. A particle needs momentum. Right here. The energy field, if that's another part. It creates gravitational field. The energy is so large that it collapses into a black hole. Yeah, because that's the thing. So energy and mass are equivalent. So if you have something going super fast, it's also creating a gravity as well. So that's also included in here as well. I think I close it. So if you click on if I click on field, so that's another part that's very interesting to keep in mind, because as something goes further, let's keep it like gravitational effect. Yeah, so here.
In response to energy and mass. As we focus increasing amounts of energy into smaller and smaller regions, the gravitational effect of that energy becomes significant. The surrounding spacetime starts to warp. pushing
so basically, if energy and mass are equivalent, as you go, it's going to warp into a black
further
hole.
still, and the energy density grows so large that the region would collapse under it.
And that was the other part. But there's the other gravitational. So that's the black hole idea. Basically, as you have infinite energy, it's the same as mass. So you're going to have like a giant sun in there. And then surrounding space. And again, remember the energy you need. You need like 4,000 light years or whatever of Large Hadron Collider to speed up the energy. Just speed up using mainstream terms. Okay. Okay. Okay, this one right here. I think he mentions it here. Okay, I think it's over here. Mentions it.
Photon approaches the electron, this effective mass produces a tiny gravitational field pulling on the electron. Now, put the effective mass written as hf divided by c squared. Now, here is the key point. As the photon approaches the electron, this effective mass produces a tiny gravitational field pulling on the electron. Now, if the characteristic distance over which the interaction occurs...
this is, again, to measure something you need to bounce it off, so if you're going to have a light photon electron bouncing off, as you go super, super fast, you can't ignore the gravity part, and that's why it adds to the uncertainty there. So that's why this part right here, as you increase the momentum right here, you basically have again, you increase momentum energy, you're going to have this gravitational part that's just going to keep going up. And that's this red part. That just keeps going up and up. I'm pretty sure that's the red part. Yeah, let's go back here. Let's go, yeah, new source of gravitational uncertainty. That's this part right here. So click
by the speed of light. And if we sub this into our displacement equation, we find that delta x can be written as gp divided by c cubed. Finally, if you recall, the photon's momentum is of the same order of magnitude as the uncertainty in the electron's momentum, and so we can rewrite the electron displacement in terms of the momentum uncertainty. And there we have it. This represents a new source of gravitationally induced uncertainty. And so we can now combine this with the ordinary run-of-the-mill quantum mechanical uncertainty relation that we love and know so well. And when we do, we end up with a modified version of the uncertainty principle, one that goes by the name of the generalized uncertainty principle. Now, to get a sense of what this is telling us, let's plot this function and visualize what's going on. Okay, so if we plot delta p on the x-axis and delta x on the y-axis, then we see that the green curve represents the first term and shows how reducing the position uncertainty increases the momentum uncertainty. The red line shows the new gravitational term, whereby increasing the momentum uncertainty increases the positional uncertainty. And then finally, the blue line shows the combined effect.
Okay, yeah, so basically, to get better resolution, you're going to have uncertainty and momentum. But then when you have uncertainty and momentum, again, you're getting super, super high. You're going to have uncertainty in the gravity, and that's going to make it just constantly going up and up. And so on. And also, the other part, the reason for the uncertainty, according to, if you look at this setup right here, basically, when you try to measure something that's less than this, so when you measure according to Fractal-Ullmann's modified unit analysis setup here, so to measure something that's less than a wavelength, you're gonna have uncertainty because you only know the quantum is this full wavelength right here. Anything less than it is gonna be an approximation. So as you get smaller, you're gonna have to approximate with different, because to get that energy, you're gonna, first of all, you got to get to that, and then second of all, if it's anything less or comparable, you're gonna have some errors in it. Anyway, so that's that part. We have about 5 or 6 minutes there. I just want to keep going this one here. So Heisenberg uncertainty, probe distance, a particle needs momentum. The energy creates a gravitational field. If this is less than, if delta x is less than the Planck length, the energy is so large that it collapses into a black hole whose event horizon is greater than delta x, hiding the region from observation. Yeah, so the black hole itself hides it. Quantum foam, space-time. So for virtual particle and anti-particle pairs create metric fluctuations. This is delta G or something. One strong enough to make distance ill-defined. No known probe. All known interactions, photons, gravitons have wavelengths of greater than greater than the Planck length to resolve. But sending such probe requires energies greater than Planck length, Planck energy, far beyond any accelerator. information theoretical limit. Encoding a measurement below would require a greater than 1 bit per Planck area on any surface violating the Planck. Yes, you basically need high energy, infinite. There are derivations methods for that. Dimensional analysis, black hole uncertainty, quantum Schwartz equivalence, again, natural units. Theories describing F string theory, fundamentals are 1T there, loop quantum gravity, asymptotic safety quantum gravity becomes, anyways, causal holographic principle, and that, and then Planck is not merely small, it is a scale where quantum mechanics, gravity, and causality enforce a fundamental limit on measurement. And classical space-time description, different theories agree on its order of magnitude, but differ on whether it is strict cutoff, a minimal unresolvable distance, or an emergent phenomenon. Yeah, that's pretty wild stuff there. I'll put this link in here, and I'll read the last. I'll read one more page of the INLD News one. And again, note these streams are for my sake, to force myself to get the brain going, because I realize one thing, I can go off on a tangent like no other. Okay, anyways, continue back on to this right here. This one right here. Okay, so the experimental background of the laws of electrostatics, how the I'll read I think I'll read this next chapter. Yes, I'll read this up to which part? I think. Okay, how far can we go? He's going strong. Okay, we'll go until I give up. So the experimental background of the laws of electrostatics, how the electric charges were invented, and I think I might even post this on Hive blockchain. I'll ask him for permission. I want to post this as an article, because this is it deserves to be more than just a PDF. The experimental background of the laws of electrostatics, how the electric charges were invented, a digression into the atomic structure. So what exactly are the electrostatic phenomena that any theory of electrostatics should be able to explain? The list of 6 electrostatic phenomena below, II1 is the most comprehensive due to the inclusion of the last item. Not commonly mentioned in the modern textbooks of physics. Attraction, yeah, so list of them. This is the list of 6 electrostatic phenomena below is the most comprehensive due to the inclusion of the last one. So he's including the last item, not commonly mentioned in orthodox textbooks. So to get a theory, you need all 6 of these things. So attraction between a body positively charged and one negatively charged. So you need to explain attraction between that. Attraction between a body positively charged and one uncharged. So that's another thing you need to explain. Attraction between a body negatively charged and one uncharged. So why is there attraction? And now we have repulsion between 2 positively charged bodies. Repulsion between 2 negatively charged bodies. And now there's a 6th one, which he says isn't included anywhere else. Attraction then may occur between 2 bodies that have charges of the same sign, but with the charge on one of them relatively weak. All right, there it is. This makes absolutely amazing sense here. So you need to explain. So not just repulsion between like charges, but attraction between like charges if one of them is weaker. All right. Okay, so this is something I never thought of there. Okay, that's pretty good. Let us recall briefly how the artificial concepts of electric charge, positive, negative, have been invented. And I think I might just do charges next week on this. Yeah, all of this. It is best to start with Benjamin Franklin's theory that explained the charging of a glass rod by rubbing it with a piece of silk. He considered that through rubbing, the glass rod gained some electric fluid from the piece of silk, which piece of silk was therefore considered to have lost some of its electric fluid. Since glass gained electric fluid, it contained more than its normal quantity of electric fluid it had before rubbing. And because of this excess of electric fluid, it was called Franklin charge positive charge. So basically, it's grabbing fluid. Another one is now empty of fluid. Wants it back. The silk, since its loss of its electric fluid, had deficit of electric fluid and was called charge negative. So it was called negative because it lost it. There were no 2 types of electricity at the stage of development of the electrical science. There was only electric fluid that was transferred from one object to another through rubbing in a very similar way to water that can be transferred from one container to the other. Charge meant simply a load of electric fluid in the case of glass, and by extension a deficit of electric fluid in the case of silk. The topic of electric fluid was discussed in a previous work of the series, II2, previous one, where it was assigned the name electrogen. There's basically electric fluid, he's called electrogen. A place in the periodic table of elements, the chemical symbol E, and considered to have no, quote, electric charge of its own, in the sense that electric charge is understood today. In fact, the, quote, II3 clearly shows that the electric fluid was considered an element also by Franklin itself. So he considered it as an element, as basically saying there's another element, electric fluid. So the idea of electric fluid as a distinct chemical element should not appear so unusual to anybody today. Yeah, so basically saying electric fluid is a separate one, electrogen. I think we talked about that before, but we'll keep going further. So this observation suggested to Franklin that the same hypothesis that unknown to him had been propounded a few months previously by Watson, namely that electricity is an element present in a certain proportion in all matter in its normal condition. Underlined, added. So is an element. Electricity is an element present in. Yeah, is an element present in a certain proportion in all matter in its normal condition. It is worth noting here Watson's hypothesis mentioned in the quote II-5, according to which the electric field existed and was at the origin of the electric effects. Yeah, electric fluid existed and was the origin of electric effects. Okay, so it's pretty epic stuff. Yeah, I think we'll continue on later, but I want to continue with the this guy's name. So what's his name? Benjamin Franklin. So again, Benjamin Franklin. Who we talking about? Benjamin Franklin, the U.S. founding father. U.S. founding father Benjamin Franklin wrote in 1751 about lightning strikes being able to melt metal without heat and called it cold fusion. So this was, again, 1751, you can't make stuff up. 1751, experiments and observations on electricity made at Philadelphia in America by Mr. Benjamin Franklin and communicated in several letters to Mr. P. Colson and so on. Let's go back here. Okay, metals are often melted by lightning. Lightning melts metals. Lightning melts metals. Again, that could be some electric fluid that just take off. Though perhaps not from heat in the lightning, nor altogether from agitated fire in the metals. For as water body can insinuate itself between the particles of metal. Yeah, for as whatever body can insinuate itself between the particles of metal and overcome the attraction by which they cohere, as sun-dry minstrel can, will make the solid become a fluid as well as a fire, yet without heating it. So it can make a solid become a fluid and fire by removing the bonds between it. Without fire, so with electrical fire or lightning, creating a violent repulsion between the particles of the metal, it passes through the metal's fuse, so you could fuse it by putting lightning through it, cold fusion. If you would, by violent fire, melt off the metal, the end of a nail, which is half driven into a door, the heat given the whole nail before a part would melt must burn the board it sticks on, and the metal melted part would burn the floor it dropped on. But if a sword can be melted in the scabbard and money in a man's pocket by lightning without burning, either it must be a cold fusion. Okay, this is just absolutely mind-boggling. And I heard there's a 137. Okay, alpha 1 over 137. Okay, interesting. Yeah, that is the constant there. Pretty well. Okay, anyways, I will send this. Interesting how the narrator says that X-rays with wavelengths of around 1 nano can reveal individual molecules and even atomic structure of crystals, but then proceeds to molecules, crystalline structure. Yeah, that is pretty interesting. Yeah, I don't know why it shows atomic there. I think this was yeah, crystalline structure. You can show molecules with X-rays. Let's see, molecules with X-rays. Yeah, I don't know why he shows that. Yeah, that was a good idea. Why is the molecule X-ray? X-ray, and you could, Grandberg can take an X-ray molecular.
Purified and concentrated as a crystal computer into a 3D map of the protein's electron density. Initially, researchers like the location of each atom inside a protein structure was recorded became one of the most.
I just want to see this. I think it's something like this. X-ray crystallography and so on. You're gonna get some images of that. Let me be for another. Yeah, but basically you shoot it off and then you get a bunch of lines on there and you gotta use AI or whatever to put it back together. Molecular movies.
The DNA in our cell.
Anyways, that's for another day. That's this part there, and then and yeah, and definitely the Einaldini one. I gotta. I'll ask him right now. This is the cycle manifesto. Einaldini is again. He is a very very interesting person there. But I think he doesn't quite understand how big of a work he's doing. He's trying to like patent or something. I don't know what he's trying to do. Anyways, I will ask him to actually I'll just publish it. I really don't. Actually, I'll ask him right now. I'm gonna email him right now, and then that's it. Einaldini, because I have his email. Einaldini. Okay, thanks for the invitation. If anyone wants to see you there. Hi, hi again, didn't you? Because I asked him for to join live stream last year. Hope you are doing well. I would like to publish your paper. Okay, let's go. Yeah, publish your paper as an article on the Hive blockchain for preservation and proper viewing. Yeah, and better overall viewing. Okay, this is this paper fundamentals. I'll go science. I think I'll go to benefactor or yeah, beneficent TV demonstrates vortex. I'll go to the paper. I'll give an example. Oops, this is warning. Okay. Okay, yeah, this one right here. Please, let me know if this is okay with you. I will. Yeah, here is an example of another article that I posted from another researcher. Cheers. Very interesting. The space station enables experiments not plausible on Earth. Yeah, that's the name of the game. I hope you're doing well. And also, apparently, the space station is the most expensive thing ever constructed in mainstream. Okay. Okay. And anyways, I just sent out the I know the new. All right, guys. You guys are seeing the ground floor of big things. Yeah, happening. All right. So definitely get that. Just because the article format is just much better. You don't need to like, you can modify the back. You can have a different colors on the. You can like, modify this color. You could change everything. You could shrink the thing, make it bigger, smaller. You use it on your phone and so on. We do not hear much about these experiments. Yeah, it's a lot of these technical and so on. I want to get to here quickly. ISS most expensive. Object in the world. Apparently, it's the most expensive according to mainstream terms. It's like 100 and yeah. So internal station considered the most expensive object in the world with an estimated cost of over 150 billion. Interesting. And now Elon Musk is gonna be a trillionaire. And then so he's gonna get like 25% of Tesla if he can get their valuation 10x. Yeah, so you can see Elon Musk would become first trillionaire as Tesla shareholders approve giant pay package and then contingent on him producing like a bunch of robots and so on. Must deliver 20 million Tesla robots and more than double the number since the founding and also 1 million of his human-like robots by the year in 10 years. So everything's well done up. Anyways, guys, that is all. I'll end this quickly here. Where am I posting these links here? Okay, this one should be. Okay, I'm gonna stop the record. Okay, guys, that's all for today. Again, made 10 cents off that post. Again, that's epic stuff there. That's all for today, guys. Okay, thanks for joining. And nobody else commented anywhere else, but whatever. Thanks for joining. And yeah, also Beneficent TV is gonna be joining the show. So Benefactor on this Saturday, and I'll hopefully be talking about Hive and his projects. Thanks for joining, and have a great day. I'm gonna take a nap. Where do people think Black Ops money goes? Yeah, it goes to their Epstein Diddy parties on the moon or something on Mars. All right, that's it, guys. I'm ending the stream in 3, 2, 1.